Hey guys, what's up people? Welcome to today's session. How are you guys doing? I hope all of you guys are doing good, taking care of yourself. I know it's been a long time since we have last met, since I've come on YouTube live or premiered. There's been a lot of personal things that has been going on. But I hope that all of you guys are doing good, taking care of yourself, and your preparations are going really strong. Since the syllabus is also out already, I'm hoping that you guys are giving your 100% in your preparations for both your term 1 as well as your term 2. But anyways guys, to help you guys out, I'm here. Welcome to today's session, Prodigy session number 8. It's actually not 7, it's actually the 8th session of light, where we are going to start with refraction. Now I know that a lot of you guys have a lot of doubts regarding refraction, so guys, again, whatever doubts you have, please let me know in the comment section. I am keeping an eye out for that, so whatever doubts you have, please put it down over there so that I can get those doubts cleared and answered as well, right? So anyways, without wasting any more of your valuable time, let's get started with today's session. Now before I get started guys, let me give you a couple of announcements that are very important, that's going to help you to understand and to stay in touch with us as well. So we have a Telegram group for our Vedantu 9th and 10th English channel. So if you want, you can take down this link, people, and join that group where you can connect with your master teachers, all of the master teachers. You can get the regular schedules of all the sessions that's going to happen on that particular day, and you can also get faster updates of everything that's going on around. And with this, people, we also have the pro exclusive micro course. More about it, I'll talk about it towards the end, but let me give you a hint guys. This is the opportunity for you guys to study with me and all the other amazing teachers on the Vedantu platform as well. And at this point of time, we have master electricity like never before going on. So if you want to be a part of it, you can also enroll into those courses as well. I'll talk more about the pro exclusive courses later on, but without wasting any time, let's get into the backtrack round. Now, as you guys know, people, MCQs have become a very important part of your exam preparations. Term 1, you're going to have a lot of MCQs. You're going to have only MCQs, so you have to be better prepared for it. So keeping that in mind, people, we have the backtrack round. So where I'm going to ask you a couple of questions that we had studied in the previous session, and all of them are going to be MCQ based itself. But what I want you guys to do is be honest to yourself and try to answer the questions very honestly and very diligently. So try to think about the answers. Don't just rush into it. Give the right answers either in the comment section or to yourself, but make sure that you think about it before you answer, right? Because yes guys, exams are coming up. So here's the first one. When light falls on a smooth polished surface, most of it is reflected in the same direction, is reflected in different direction, is scattered, or can't see. If light falls on a smooth and polished surface. Now remember guys, I'm going to give you about 10 to 15 seconds to read the question, but in your exams you'll have enough time. You know that it's a 90 minutes paper, so you have a lot of time to read the questions. Since it's a video, what I'm going to do is I'm going to give you 10 seconds. What I want you people to do is pause the video if you need more time to think about the answer, and then write down the answers. All right. But anyways guys, I'll tell the answer in 5, 4, 3, 2, 1. It's going to be option number A, people, because when you have a smooth surface, it's going to be a regular reflection, and in regular reflection, the rays of light are going to be parallel. The reflected rays of light are going to be parallel to one another as well. So over there, you would see that most of the ray of light would get reflected back in the exact same direction if it falls on a plane mirror. Whereas if it falls on an irregular surface, then you have something called as a diffused reflection there. And in diffused reflection, the light ray might get reflected in different angles. But when you talk about regular reflection, the reflected ray would be reflected back in the exact same direction. All right. So that's the answer for the first question, people. I hope you got it right. I'm pretty sure that you did, because it's not a new concept. But if you got it wrong, you must focus on your basics, people. Come on. Next one. Here's another one. When a plane mirror is rotated through a certain angle, the reflected ray turns through twice as much, and the size of the image will be what? A plane mirror is rotated through a certain angle. The reflected ray turns through twice as much. what would happen to the size of the image? Would it also double? Would it become half of it? Would it become infinite, or would it remain the same? It's a very tricky question, but it's actually quite simple. Let's see how many of you guys are able to pay attention to that. And once again, guys, I'm hoping that you guys can hear me clearly. I hope there's no echo and all that, because I'm in a different location right now. So probably you guys might not be able to hear me as clearly as you did before. So I apologize for that. It's going to be there for a couple of days, and then once I get back to my place, it's going to be all fine. Right? So anyways, guys, let me give out the answer for this one as well. 10 seconds is all that I'm going to give you. Again, guys, if you need more time, pause the video and then give the answer. All right? In 5, 4, 3, 2, 1. The answer, guys, is actually quite simple. It's going to remain the same. You know why? Because it's clearly mentioned that it's a plane mirror. And one of the major properties of a plane mirror, or the properties of the image formed by a plane mirror, is that the image is always going to be of the same size. If you are 5 feet tall, the image is also going to be 5 feet tall. There's not going to be any difference in the size of the image, right? And the distance of the image also, as you guys know, is exactly the same. So if you're 5 meters away from the mirror, the image formed will also be 5 meters away from the mirror, right? So simple, easy question. Just trying to trick your mind a little, but it's actually quite simple. Here's another one. So this will be the last backtrack question. After this, we'll move on to the topic for today, and then we'll have another quiz after that as well. So stay tuned for that. Make sure you solve those MCQs also. Do not leave any MCQs whatsoever. All right. It's a new pattern. You must start practicing those questions, and there's no better way to do it, right? Here's another one. What helps in finding the direction of the reflected rays? Is it the laws of reflection? Is it the laws of motion? Is it the laws of gravitation? Or none of these? Which of these helps in finding the direction of a reflected ray? Come on, guys. This has got to be. This is like this is like more like a spoon. This is like, they say that, right, in cricket and all. They have this something called as this underarm ball or trial ball. I don't know what you call it as, but yeah, you have something like that. No, the first ball which they put very slowly so they can hit a 6 and all for your warm up. That's what this is. Anyways, the answer, I'm pretty sure everyone got it right, but let me just give you the answer anyways for all those who got it wrong. It's laws of reflection, people, because yeah, I mean, the answer is there in the question itself. The one that's going to help you to find out the direction of the reflected ray is going to be the laws of reflection, which are basically two. One is that the angle of incidence is equal to angle of reflection. Second is that the incident ray, the reflected ray, and the normal, they all lie in the same plane. That's it. Simple as that. So yeah, guys, with that said, let's get into the topic for today then. I hope you guys are ready for this one. It's going to be quite an easy one. It's not going to be a difficult one. It's just the basic of refraction. So get prepared, get ready mentally to absorb the information. Now, if in case you're not able to understand anything on the way, let me know that also in the comment section so that we can do some experiments on it. I might try out something different to help you guys understand the concept better, right? Okay, what is refraction? Now, the concept of refraction is not something which is new in life. In fact, pretty much every one of you guys would have experienced this at least once in your life. But how do you define it, and how do you explain it in words that are easy to understand, right? That is the question that we are going to answer today. So what is refraction? I'm going to explain this with a simple analogy, guys. Imagine a car, all right? Now the car, as you can see, is traveling from a tar road onto a muddy road. All right, the car is traveling from a tar road onto a muddy road. Now, if you look at the car carefully, the car was traveling in a straight line, and then as it entered into the muddy road, it slightly tilted towards the left. I hope you can see the GIF. You can see that it's slightly tilted to the left. But why did that happen? What is the reason? Let's understand that. Look at the left tires of the car, guys. All right, look at the front left tire. All right. Now, the front left tire is the first one that is entering into the mud, right? From the tar road, that is the first tire that is entering into the muddy road. And then comes your front right tire. Now, what happens is this, guys. As soon as the left front tire enters into the muddy road, it suddenly slows down. And because it suddenly slows down, what happens is that the car slightly tilts towards the left. Now, what has this got to do with refraction? Because here's the thing, guys, the same thing happens to a ray of light as well. When light is traveling from one medium into another. Now, in this case, the car is traveling from a tar road onto a muddy road. So basically, the type of material that is there is different in both of them. The properties are completely different. The kind of friction that you get is different. Pretty much everything about these two different roads are different, right? Muddy road is muddy, whereas a tar road is tar road. It's more solid, right? And the same thing happens in light also. When light is traveling from one medium to another, be it air to water, water to air, or vacuum to air, or it could be, any n number, oil to water, whatever it is, whatever the medium is. When light is traveling from one medium to another, light also slows down a little. And when that slowing down of light happens, the path of light slowly changes. Or in simple words, the bending of ray of light is what is called as refraction. Now, look at this glass. So this you see the second glass? You can see the second glass. There's no water in there. It's just air. And you've put a straw into that particular glass, and you see that the straw looks straight. No difference whatsoever. But as soon as you put some water into it, now the light is traveling from air into water. Two different medium, right? It's traveling from air to water. So what happens? Light slows down because it's traveling from one medium to another. And when that happens, what happens? The bending of light ray happens. Just like the car changing its path slightly because of that change in speed, light also changes its path very slightly. And that is why you see this, guys. The straw looks like it's been cut in half and then, it's been displaced or something, or it's been shifted halfway through. But is that how the actual straw is? No, that's not the case. But it appears as though the straw is bent. And that, my friends, is all thanks to refraction. That is the magic of physics. That is the magic of refraction. And in simple words, guys, this is what is refraction. The bending of ray of light when light is traveling from one medium to another is what is refraction. As simple as that. Now, guys, the thing about refraction is this. You know why we see it this way? For example, people, look at this one, right? Is the straw actually bent? Is the glass straw actually bent? No, it's not. But it appears as though it's a little bent. Now, why is that so? See, guys, look at this. This is the actual, imagine a pencil inside a beaker of water or a glass of water, whatever you want to imagine. And this is you, right? This is you standing over here with your big eyes and watching this pencil right there. And there are two rays of light. Imagine two rays of light are coming from the bottom of this pen, right? And as the light is traveling from one medium to another, from water into glass, light would change its path ever so slightly. That is, the bending of light happens. And the light's path, which was the actual path, was supposed to be straight. But then because of this bending of light, light basically traveled a little towards the right. Right? That's what's happening over here. So you can see that those two rays of light are traveling towards the right. And it falls into your eyes, forming a tiny little image. But here's the thing, guys. Our eyes, our brains, our eyes are sometimes, buddhus. Like, what do you call it? Sometimes we don't think so clearly. Sometimes our mind and our eyes can play tricks on us. Now, what is that trick? Say, guys, your eyes wants to know where the light is coming from. What is the source of light? So what does it do? It tries to trace back where it came from. Our eyes becomes Sherlock Holmes for a minute there. So what happens then? It tries to trace back the steps. But when it tries to trace back these rays of light, what happens is that, guys, the rays of light actually meet at a point a little higher than the original object. See, this is where the actual object is. But then to your eyes, when you are looking through the glass of water, it appears as though the pencil is a little raised. And this is why, guys, this is why refraction is something that I told is something that you guys have experienced pretty much every single day, and you will be experiencing this for the rest of your life as well. But this is the reason why a bucket of water looks a little raised. Yeah, next time you go to the washroom, just check it out. A bucket of water, the bottom part of it would look a little raised. Why? Because of refraction. All because our mind is playing this illusion, forming this image, which is not actually true, right? Because this is the actual object. X is the actual object, but your mind's illusion, the image that is formed, is going to be a little bit more higher, which is what is called as the image or just an illusion. Right, guys? And this is what is refraction, the bending of light. When light enters from one medium to another is what is refraction. But the question is, why? Right? Why does light bend? We understood that light bends. It's very clear now. But why does it bend? Why does it have to bend when it's traveling from one medium to another? Why does it not bend in the same medium? When light is traveling in air, why does it not bend? When light is traveling in water alone, why does it not bend? Why only when it is traveling from one medium to another? I'm going to show you a table for that. Look at this table, people. Can you see something different? Now, look at this, guys. This is all the values of speed of light in different mediums. All right. So you have vacuum, where the speed of light is 300,000 kilometer per second. Air, the speed of light is 299,000 kilometer per second. Ice is 229,000 kilometer per second, sorry. And water is 225,000 kilometer per second. And finally, glass, 197,000 kilometer per second. There's something different, right? What's that? The values, isn't it? The speed of light is different in different mediums. And this one reason, people, because of the speed of light being different in different mediums, what happens is that the ray of light bends when it's traveling from one medium to another. And always remember this, guys. The speed of light in rarer mediums, that is mediums whose density is a little less, in those mediums, the speed of light would be very high. For example, vacuum and air, the density is very, very less. So in those, you can see that the speed of light is very high. But the denser medium that you have, where the density of the medium is much more higher, speed of light is going to be much more lesser there. For example, glass, water. In comparison, speed of light is much more slower in those because the densities of those mediums are much more higher. So if I have a ray of light that is coming and incidenting on this surface, on a glass slab, all right, imagine it's a glass slab. So what happens is that light, because it is traveling from air to glass, and the speed of light in glass is much more lesser, the light ray would slightly bend. And how does it bend? That is where it gets a little bit more interesting. Now, always remember this, guys. Please don't ever forget this, because you would be needing this for the rest of your 10th standard. So please remember this, that when light is traveling from a rarer medium to denser medium, from a rarer medium to a denser medium, light would bend towards the normal. What is it going to do? It's going to bend towards the normal. When it's traveling from rarer medium to denser medium, it will travel towards the normal. This is supposed to be the original path of light, but what happens? It is changing ever so slightly. And again, what is that? Refraction. And again, guys, this refracted ray, as it leaves the glass slab, because glass is a transparent medium, so once whatever enters should leave, right? So when it leaves this glass slab, the light is traveling from a denser medium, that is glass, to a rarer medium, which is nothing but air. And here, guys, light is going to bend away from the normal, not towards it, but away from the normal. When light is traveling from rarer to denser towards the normal, from denser to rarer, light would travel away from the normal. You can see this. This is your normal. This is the original path of light that is how the ray of light was supposed to go. But you can see that it's going away from the normal. And that, my friends, is a hardcore truth, and it is something that you must never, ever, ever, ever forget, right? And yes, guys, if you look at it very carefully, if you look at it there's something peculiar about this ray. So this ray of light that is coming out of the glass slab is called as the emergent ray, because it's emerging out of the glass slab, right? So it's called as the emergent ray. Now, if I extend the incident ray, that is the ray of light that came and fell on this glass slab, if I extend it, you can see that the ray of light is slightly shifted, laterally shifted. It is basically, it's like someone picked up this ray of light and moved it a little. So this is what is called as the lateral shift, or in simple words, it's also called as a shift. All right, so the ray of light gets laterally shifted when light is traveling from a rarer medium, that is like air, into a glass slab. All right, and this is what your ray diagram looks like. So this is your incident angle, which is basically represented by the letter I. This is your refracted angle, and you can see that here is your second ray, that is the second incident ray on the glass slab, that is when it's leaving from the glass slab into air. And again, you can see that this is nothing but your emergent angle. You can call that as your angle of emergence, right? So this is how light acts. Now we'll be studying more about this. We'll be going in detail about all of this in the topics in the days ahead. So stay tuned for the channel, guys. Make sure you subscribe to the channel, because we have some amazing stuff coming your way. So make sure you subscribe, like the video, and let me know what you think about the session in the comment section. But don't leave yet, people. We still have a lot of questions to solve. MCQs are very important. But before that, guys, I also have something super amazing for you guys. NTSEs are right around the corner, and more than 100 students from Vedantu have been selected or have cleared their NTSE stage 2, and that is a massive news, people. Stage 2, first of all, is not a small thing, and that too in NTSE, that's not at all a small thing. And if you want to be one of those toppers to clear your NTSE, guys, Vedantu's starting the live NTSE crash course, India's first ever NTSE online course, which not only would help you in your board preparation, but also in your NTSE preparations. Now, I don't need to tell you how important NTSE is. You guys already know about it. But for all those who do not have an idea what NTSE is something which basically gives you, if you clear this first and the second stage, it gives you a scholarship until basically you do your PG, that is your postgraduate or undergraduate, whatever you decide to do in your future. Until then, they'll be giving you scholarships for this. So it is not a small deal at all. And you also get the brand of an NTSE scholar, which is not a small thing at all, because you have this IIT brand, right? It's a brand. IIT is a brand. In the same way, guys, you also get that NTSE brand, which you can put in your resume, which can add value to the rest of your life as well. So what are you waiting for, people? All of the subjects, physics, chemistry, bio, mental ability test, and your social studies, all of it would be covered with more than 139 selections in NTSE 2020 and 2021, and we're still counting. It is the highest in any institute, not only online but offline also. It is the highest in any institute. We are offering you, people, 60 plus live classes for both stage 1 as well as stage 2 preparations, with more than 50 chapter wise tests and more than 14 mock tests for your NTSE preparations. And yes, guys, all of these sessions would be recorded, and you can watch it at any time, wherever you like it, whenever you like it. And added bonus, people, unlimited doubt solving inside the class as well as outside the class with the help of Vedantu's doubt solving app. You can also get the in-depth solutions of the NTSE mock test papers that you're going to give. You can understand where you went wrong and make those corrections. And finally, guys, you can also get the entire summary of all the sessions, get the concepts, the formulas, all of it, and get 10% off also. Yes, people, all you have to do is go to the link in the description and click on that particular link, which would take you to the Vedantu website. and you can select the course over there. Unfortunately, I have not opened up the website over here, or else I would have showed you that, but next session I'll show you that as well. Do not worry guys, but it's given in the description. You can check it out for yourself and you can be a part of Vedantu. Right? But anyways guys, let's solve some quiz questions right now because MCQs are important. So let's solve some. Now make sure again guys, be honest. 10 seconds. If you need more time, pause the video and take more time, how much ever time you want, but make sure that you give the right answer. All right. So here is your first question. Light travels fastest in which of these? Water, air, glass, or diamond? Light travels fastest in which of these? Water, air, glass, or diamond? Yeah, I've already shown you the table. Now, if you need to go back to the table, go back to the timestamp where you saw the table, but don't Google it. Don't Google it. I don't want you guys to Google it. Try your best to give the right answer without Googling or going back. Let's see how many of you guys get it right. And be honest. Let me know how many of you guys were honest in the chat box. All right. Give me a oh yeah if you guys were honest. All right. I'll be looking out for that oh yeah. All right. That means you guys were honest. If you guys were not, then give me a nay sir, nay nay. All right. Okay. Be honest. For that also don't lie now. All right. So here's the question. Light travels faster than which of these guys? Water, air, glass, or diamond? It is air, guys. Air has very less density. It's a rarer. It's comparatively very rarer medium. It's a very rarer medium. That means the density is less. And so, guys, speed of light is very fast in air. So speed of light is close to 299,000 kilometer per second in air. In water, it's a little slow. In glass, it's even more slower. In diamond, it is the slowest comparing when you compare all the three. Right. Moving on to the next one, guys. The deviation of light ray from its path when it travels from one transparent medium into another transparent medium is called as what? Yeah, rocket science people. Come on. Reflection, dispersion, refraction, or scattering of light. What is the deviation of light ray from its path when it's traveling from one transparent medium into another transparent medium? I'll leave the answer in 5, 4, 3, 2, 1. It's refraction, not reflection. All right, it's a refraction. Refraction is what is known as the bending of light when it's traveling from one medium to another. All right, don't get that wrong, people. We have spent almost 30-45 minutes to explain the concepts, so don't get that wrong because I'll be teaching you guys more in-depth concepts in the next one. So make sure that you make the basics right. All right, and make sure you subscribe to the channel because obviously, if you want more helps, subscribe. Next one. The path of ray of light coming from air passing through a rectangular glass slab. Imagine a ray of light incidenting on a rectangular glass slab. 4 students are tracing the path of this. All right, and they've made it as A, B, C, and D. So there are one student has traced the path as A, one student as B, one student as C, and one student as D. Which of them is the correct figure? All right, a ray of light is coming from air to glass. All right, so it's a glass slab. Which of these do you think would be the right or correct path of ray of light? A, B, C, or D? Super easy question, guys. I'm pretty sure you guys would have figured it out. But all those who are still confused, I've already done it. Go through the video if you have to. But let me give you the answer in 5, 4, 3, 2, 1. It is definitely going to be option number B, guys. Because why? Again, the ray of light is bending as it is traveling from air to glass. And this time it will bend towards the normal. And as the ray of light is leaving the glass and entering into air, it will move away from the normal. So yeah, that's what your ray diagram would look like. Simple. Next question, people. Here's another one. Light is slower in glass than in water. Fact. If light travels water to glass, it turns towards the normal, away from the normal. It won't bend at all or can't say. Let me repeat the question, guys. Light is slower in glass than in water because glass is a denser medium. If light is traveling from water to glass, would it bend towards the normal, away from the normal? It won't bend at all or can't say. Let's see how many of you guys are paying attention. Anyways, I will give you guys 10 seconds. If you need more time, I'm pretty sure you guys need more time for this. Pause the video, give the right answer in the comment section. Let's see how many of you guys. Again, be honest, guys. I'll also give you a homework question. Be honest in that also. All right. Honesty is the best policy. All right. Policy, not LIC policy. Peace policy for life. All right. In 5, 4, 3, 2, 1. Here's the thing, guys. In comparison, when you compare water and glass, water is a rarer medium and glass becomes the denser medium when you compare both these. All right. Water is the rarer medium and glass is the denser medium. And since light is traveling from a rarer to a denser medium, it will do what? It will bend towards the normal, not away from it, but bend towards the normal. Alright guys, and yeah people, this is your homework question. It's a super easy question, but let me know what is the answer in the comment section. The question is, if the speed of light is high in a medium, the medium is what? Is it a rarer medium or a denser medium? Let me know in the comment section. Let me know how the session was, and let me know how you guys have been. All right, so that's all for today guys. But yes, again guys, the pro exclusive micro course is going on right now as we speak. Master electricity like never before is going on right now. If you want to be a part of it, you have to enroll into the pro subscription course, which the description to that is also given in the comment section. So in the comment section as well as in the description box. So check it out for yourself and see how Vedantu can help you guys. Again guys, House of Toppers is what Vedantu is all about. All right, and we are giving you a guarantee that your scores would improve. What more do you want? 2-term exams, people, term 1 and term 2. So take it very, very seriously and start your preparations right away. Don't wait till the end. All right, so that's it for today guys. Thank you for joining. Catch you guys in the next session. Hope you enjoyed it. I'll see you guys soon. Have a great day ahead. Until the next time we meet, this is Anoop signing off for the day. Have a great evening. Subscribe to the channel, like the video, share the video to your friends as well, and see you soon. Bye guys, take care, enjoy.